Hi, and welcome to my channel. If you're new here, welcome. We're going to do some maths and have some fun. So today, what we're going to learn is how to solve simultaneous equations using elimination. And by the end of this lesson, you're going to be an expert at it. So let's dive in. So let's start off with a easy example. Suppose we have two equations. The first one just being x plus y equals to 10. And we're going to call this equation 1. And then my second equation is just x minus y equals to 2. So let's call this equation 2. So I'm given two equations and I want to solve this simultaneously. So what I need to ask myself is there a way I could... so we're going to solve this simultaneously using elimination. So I'm going to ask myself, can we eliminate either the x or the y in this equation? And we could do either. And it's probably easier to do the x's in this case because they're both positive. So we could just get rid of them simply by just subtracting them both. So let's write out what we're doing. So we're going to do equation 1, take equation 2. So on the slide, I'm just going to write out what I'm doing. Equation 1, take equation 2. And so if you do x take away x, that eliminates it. We get rid of it, which is perfect. This is where it gets a bit confusing. Be careful of this. This is y take away negative y. Y take away negative y. And remember, when you have two negatives next to each other, it becomes positive. So y take away negative y is actually y plus y. And y plus y is 2y. So I'm going to write 2y over here. And then we still have the equal sign. And then finally, we just have 10 take 2, which is 8. So 2y equals to 8. And to get rid of the 2, we just want y by itself. You're going to divide both sides by 2. And that just leaves the y. And 8 divided by 2 is 4. So that tells me y is 4. Now what I need to do, this is something that people forget to do, is you need to substitute this back into either equation 1 or 2 to figure out what x is. Let's just sub it into 1. So sub y equals to 4 into equation 1. I really like to write out the steps I'm doing because when you're doing this in the exam, it shows the examiner that you know exactly what you're doing. And you could pick up follow-through remarks if you get the final answer wrong. And it also helps your brain learn the maths as well. So it's really important to try and write out all the steps because it will help you remember. So what we're doing, we're subbing y equals 4 into this equation. So let's write out this equation. So we've got x plus y equals to 10. And wherever I see y, which is over here, I'm going to substitute the value 4. So I still have x. And instead of y, I'm going to say 4. And that equals to 10. And now this is quite easy to solve. We just want to isolate the x, so we need to get rid of this 4. So it's a positive 4 on this side, so to get rid of it, we just need to subtract 4. Whatever we do to one side, we have to do to the other side. That gets rid of that, and so we just have x is 10 take 4, which is 6. So my solution to this equation is x equals to 6, y equals to 4. So because these are x and y, you'll see how I just put them as coordinates. So you could write your x value first and then your y value. Perfect. Okay, let's go a bit harder. Let's try another one. So suppose, and I'll do this a bit faster because now we're all a bit more experienced at this. So suppose I'm told that my first equation is 2x plus 3y equals to 13. And my second equation is 2x minus y equals to 5. So step 1, let's label my equations. Okay, I'm going to ask myself, can I either eliminate the x's or the y's without multiplying by anything? And I can, because these two values are the same and they're both positive. It's going to be nice and easy to eliminate your two x's. All you need to do is do that, take that. So let's write out what we're doing. We're doing equation 1, take equation 2. And then let's figure that out. So 2x take 2x, that eliminates that, which is perfect. 3y take y, so again, be careful of the negatives. 3y take negative y. When you've got two negatives next to each other, it becomes a positive, so it's actually 3y plus y, which is 4y. So we have 4y, and this one's nice and easy. 13 take 5 is 8. And then we just want to get rid of the 4, so we have y by itself. So we're going to divide both sides by 4. 8 divided by 4 is 2. So y equals to 2. And then remember, all we now have to do is substitute that back into any equation. I'm going to sub it into equation 1. So let's write out the equation. 2x plus 3y equals to 13. Wherever I see y, hopefully you could recognize my y, I'm going to sub in the value 2. Now let's use brackets when I substitute it in, because when you've got a pronumeral, when you've got a number before it, it's multiplying. So we've got 2x plus 3, and instead of y, I'm going to substitute 2, and I'm going to use the brackets. And we're told it equals to 13. Okay, this is going to be a bit more fun, the algebra. We could work out what 3 times 2 is, which is 6. That's still 2x, and we've got 13 there. And then all we need to do is get rid of this 6. So we're going to subtract 6 from both sides. That gets rid of that. So we've got 2x equals 13 take 6. 13 take 6 is 7. And then all we need to do is divide both sides by 2. And so we get x is 7 on 2, or 3.5. It's a fraction. So my solution is x is 7 on 2 and y is 2. So hopefully you're feeling a bit more comfortable with this, and it's hopefully not too hard. I just want to point out some common mistakes. So the main common mistakes I see students make all the time is if the values are not the same, and we're going to do an example like that in the next question. So if the x's are not the same or the y's are not the same, we need to multiply to make them the same. But students often forget to multiply every single term. So we'll talk about that in a second, where you have to remember to multiply every single term. Another error is the signs. So be careful of the signs and how we try to eliminate them. And then the final error is, this is a really common error, students only find the first solution and then forget to substitute it back in to find the second solution. So always remember that final step to sub it back in to make sure you find out what the final solution is. Okay, let's go through a harder one. So suppose my first equation is 3x plus 2y equals to 16. And my second equation is x minus y equals to 1. Okay, and we want to solve this using elimination. So the problem over here is your x's are not the same, so it's going to be hard to eliminate them straight away. Your y's are also not the same, so you can't eliminate them straight away. So we need to make either the x is the same or the y is the same. It doesn't matter which one. Let's go with y this time, just because there's a negative here, so just so it gets a bit more interesting. So to make this y 2y, what we need to do is multiply this by 2. But you can't just multiply this by 2, you have to multiply every single term by 2. So let's write out what we're doing. So we're doing equation 2 multiplied by 2. So remember, every single term you have to multiply by 2. So x multiplied by 2 is 2x, minus y multiplied by 2 is minus 2y, 1 multiplied by 2 is 2. And let's call that equation 3. And I'm just going to rewrite equation 1 over here. So that was 3x plus 2y equals to 16. Okay, so I want to eliminate. Let's zoom in here. Let's write that a bit neater. So it was 3x plus 2y equals to 16. Okay, so let's think about this because this one's a bit tricky. I want to eliminate the y's. So if I do 2y take negative 2y, we've done a few of these negatives. When you have 2y take negative 2y, when you've got two negatives, hopefully you remember that becomes positive 2, and so it becomes 2y plus 2y, which is 4y, which doesn't help. It doesn't eliminate the y's. But if I do this plus this, so 2y plus negative 2y, that is 0, because when you got plus a negative, it just becomes minus. So that becomes minus, so it's actually 2y take 2y, which is 0. So what I'm going to do is, in order to eliminate the y's, I'm going to have to add them. So it's equation 1 plus equation 2. So hopefully that makes sense, because that plus that eliminates those two. So let's do it. So you're going to do that plus that, which is 5x, 2y plus negative 2y, which is 0, and 16 plus 2, which is 18. Okay, we don't want to know what 5x is, we want to know what x is, so you're going to divide both sides by 5. So x is just 18 on 5. So a nice fraction there. Now, remember our final step, sub that, and let's sub it into equation 2. Sub x equals 18 on 5 into equation 2. So we've got x minus y equals to 1. And instead of x, I'm going to substitute 18 on 5. So you got 18 on 5 minus y equals to 1. Okay, so let's do some rearranging. So we're going to move this neg y to the side, or we're going to add y to both sides in order to get rid of that. Let's think of it like that, actually. Add in y to both sides, so that gets rid of that. So you have 18 on 5 equals 1 plus y. And then, let's add a few more pages. We just need to get rid of this 1. So we have y by itself. So you're going to subtract 1 from both sides. That gets rid of that. So we have y over here, 18 on 5 minus 1. And we could work this out. 1, we could just, in order to do this without a calculator, we could just write 1 as 5 on 5. So, because we want it as the same base as this. And then, when the denominators are the same, you can literally just subtract the numerators. So we could just work out what 18 take 5 is, which is pretty easy, 13, and the denominator stays 5. So that's y. Y is 13 on 5. And then let's write out our solutions in coordinate form. So x was 18 on 5 and y was 13 on 5. Perfect. Well, hopefully you feel a bit better at solving simultaneous equations using elimination. If you like this video, you know the drill, do all the good stuff, subscribe, hit like, comment, and in the next video, I'm going to show you how to solve simultaneous equations using substitution. See you next time. Bye.